Today, let's study the differentiation of the inverse function of sine. Here's a seemingly complex problem. I will explain how we can find the answer in just one line through today's lesson. What you see now is the formula we'll use today, and we'll prove it later. The inverse function of sine is also written as arcsine. To differentiate it quickly without using the chain rule, we'll use the box notation. The derivative of the inverse sine box is box prime divided by the square root of 1 minus box squared. Determine what to put in the white box, and simply put the differentiated term of the white box into the green box prime, and the answer will be obtained. Now, shall we solve the first example together? Here we have y equals sine inverse x. Let's start by proving what the derivative of this function is. To understand the sine inverse function more easily, let's consider an example. If sine x is 1/3, how do we find x? Yes, it would be x equals inverse sine 1/3. To find the inverse function, we swap the x and 1/3. Let's look at our problem again. In y equals inverse sine x, if we swap x and y, we get the original function, which is x equals sine y. Now let's differentiate both sides of this equation with respect to x. On the left side, it becomes dx over dx, and on the right side, it becomes d sine y over dx. We have discussed the derivative of sine function in a previous video. The formula we use is as follows, and if you want to see more details, please refer to the link on the top right corner. For the white box, we can put y as we did in the previous example. And for the white box on the right side, we also put y. Now, we need to put the differentiated term of the white box into the green box. What would be the derivative of y with respect to x? It would be dy over dx. The left side, dx over dx becomes 1. So we have 1 equals cosine y times dy over dx. And if we isolate dy over dx, it becomes 1 over cosine y. Let's use the expression we found earlier for sine y. And this time, we'll represent this right side as x over 1 in fraction form. Now, using a right triangle, let's label the angle on the left side as y. By using mnemonics, so sine equals opposite over hypotenuse, we can identify the opposite side as x and the hypotenuse as 1. Applying the Pythagorean theorem, we can find the length of the remaining side of triangle as square root 1 minus x squared. Let's determine the value of cosine y by examining the right triangle on the left side. Using the mnemonic cosine is adjacent over hypotenuse, we find that cosine y is square root 1 minus x squared. Therefore, the expression we are looking for, dy over dx, is equal to 1 over square root 1 minus x squared. In summary, we have shown that the derivative of the inverse sine function, sine inverse, is 1 over square root 1 minus x squared. Now that the proof is complete, let's solve an example together. The first example is y equals inverse sine 3x squared. To find dy over dx, we'll use the formula mentioned earlier. Comparing the formula with our problem, we can easily see that the white box on the left should contain 3x squared. Therefore, we'll also put 3x squared in the corresponding white box on the right. Now we just need to substitute the derivative of the white box, which is 6x, into the green box. Simplifying the answer, we get 6x over square root 1 minus 9x to the power 4. We have found the answer in just one line. Let's summarize again. The derivative of the inverse sine box is box prime over square root 1 minus box squared. In other words, if we integrate box prime over square root 1 minus box squared, we'll get inverse sine box plus c. In our problem, the white box contained 3x squared, so its derivative of 6x goes in the box prime, and we can easily integrate by putting 3x squared in the right box. If you remember the derivative formula for the sine inverse function that I explained, it will also help you solve integrals more easily. Now let's move on to the second example. The second example is y equals inverse sine x over a. Let's find dy over dx using the formula we used earlier. Now, can you see what goes inside the box? It should be x over a, right? We'll put x over a in the right box on the right side as well. The derivative of x over a is 1 over a, which we'll put in the green box prime above. The answer becomes 1 over a over square root 1 minus x squared over a squared. But we need to simplify it a bit. If we multiply both numerator and denominator by a, the numerator becomes 1 and the denominator can be written as square root a squared. We can then multiply it with square root 1 minus x squared over a squared right after. Simplifying the combined square roots in the denominator, the answer becomes 1 over square root a squared minus x squared. By the way, I would like to mention that later you will learn that the integral of 1 over square root a squared minus x squared is equal to inverse sine x over a plus c. If we reverse the process we followed, it will make sense. Now let's move on to the final example. In this example, we have y equals inverse sine 2x to the power of 3. Unlike previous examples, we have an exponent 3 in this problem. As I have emphasized in my previous differentiation videos, when dealing with the problems involving exponents, we need to use the formula that is shown here. For a detailed explanation of this formula, please refer to the linked video in the top right corner. What should we put inside the box? We should put inverse sine 2x in the box, right? And the exponent value n is 3 as given in the problem. Let's change the n on the right side to 3 as well, and write 3 minus 1 as the exponent of the box. Also, put inverse sine 2x in the box, which is the same term as the one on the left side, and differentiate it to put in the green box prime at the back. Now we can find the answer. To differentiate inverse sine 2x, let's bring back the formula we used earlier. Put 2x in the white boxes on the left and the right sides, and put 2, the derivative of 2x, in the numerator's box prime. After that, we just need to put this term into the box prime on the top line. Simplifying, the answer becomes dy over dx equals 3 times inverse sine 2x to the power of 2 times 2 over square root 1 minus 4x squared. And when you write it as a single fraction, it becomes 6 times inverse sine 2x to the power of 2 over square root 1 minus 4x squared. How was today's lesson? I would greatly appreciate your valuable feedback on my videos. Your subscriptions and likes are a great source of motivation and encouragement for me in creating more videos. Thanks for watching so far. This was your Math Guardian, Alex.